Hello everyone. Today we are presenting to you a signals and systems assignment with the topic convolution theorem. What is convolution? It is a mathematical way of combining two signals to form a third signal. If we are given an input signal x of t and an impulse response h of t, then we can calculate y of t as the following. Y of t is given by integral minus infinity to infinity x of tau into h of t minus tau d tau. Now let us take an example to understand it better. If we are given an impulse response h of t equal to e of minus 3t into ut and an input signal x of t equal to u of t minus 3 minus u of t minus 5. Then, drawing the graphs for x1 of t which is equal to u of t minus 3 and x2 of t which is equal to minus u of t minus 5, we get this graph. Adding these two graphs, we get the final graph x of t which is equal to u of t minus 3 minus u of t minus 5, which ranges between 3 to 5. Now, drawing the graph of the impulse response h of tau. h of tau is given by e power minus 3t into ut and it is as follows. Now, the graph of h of minus tau is given as follows. Drawing the graph of h of t minus tau, the graph shifts to the right by t units and is as follows. This problem is divided into three cases. Let us take the first case, when t is less than 3. The graph of both h of t minus tau and x of tau is as follows. Both the graphs do not coincide. There is no overlap. Therefore, y of t is 0 for t less than 3. This is case 1. Moving on to case 2, which is where t lies between 3 and 5. Drawing the graph of h of t minus tau and x of tau, we can see that the graph overlaps between the region 3 to t. This is the overlapped region. So tau ranges for 3 to t. Now by convolution theorem, we can write y of t is equal to integral x of tau into h of t minus tau deta. We know the overlap is between 3 to t. Therefore, the integral limits range from 3 to t. And from the graph, we can see that x of tau has the value 1. And the value of h of t minus t is equal to the value of h of t minus tau is equal to e power minus 3 into t minus tau. Therefore, substituting the values in the integral, we can write integral 3 to t e power minus 3 t minus tau theta. Integrating it, taking out e power minus 3, we get e power 3t e power 3 tau deta. Now, integrating it, e power minus 3 into e power minus 3 tau by 3 with the limits 3 to t. Substituting the limits, we get e power minus 3t into e power 3t minus e power 9 by 3. This can be written as 1 minus e power minus 3 into t power t minus 3 divided by 3. Therefore, y of t is equal to 1 minus e power minus 3 into t minus 3 divided by 3 for the region 3 less than or equal to t less than 5. Moving on to case 3, where t is greater than or equal to 5. Here we can see that x of t is 0 for t less than 3 and for t greater than 5. Therefore, the overlap region here is in between 3 to 5. So, by convolution theorem, we can write y of t is equal to x of tau into h of t minus tau deta. And as the overlap region is between 3 to 5, the limits are 3 to 5. Here we can see the value of x of t is 1 and the value of h of t minus tau is equal to e power minus 3 into t minus tau. Substituting this in the given equation, we get integral 3 to 5 e power minus 3 into t minus tau theta. Now, taking e power minus 3t out, integral 3 to 5 e power minus 3t 3 tau theta. This is equal to e power minus 3t into e power 3 tau by 3 ranging from 3 to 5. Substituting these, we get e power minus 3t into e power 15 minus e power 9 divided by 3. This can be written as e power minus 3 into t minus 5 minus e power minus 3 into t minus 3 divided by 3. Therefore, y of t in the interval t greater than 5 is given by e power minus 3 into t minus 5 minus e power minus 3 into t minus 3 divided by 3. Therefore, the final solution of y of t is given by 0 for t less than 3, 1 minus e power minus 3 into t minus 3 divided by 3 for 3 less than or equal to t less than 5, and e power minus 3 into t minus 5 minus e power minus 3 into t minus 3 divided by 3 for t greater than or equal to 5.